All right. So again, thank you guys for actually staying here. How many of you have actually used Windows Azure before? Oh, wow. Thank you so much. What have you guys, I'm trying to figure out, because so many of you have touched Windows Azure, I'm trying to figure out what I should talk about. I was told to talk about Windows Azure in general, just kind of take the breadth of services that we have and also show you guys what we can do with Java. Is that still okay for you guys? Okay, awesome. So I'm not going to try to do .NET. I'm going to try to do Java on Windows Azure. It's actually my background too. I come from Sun Microsystems before. So I've always wanted to do more Java on the Microsoft stack. Now, Windows Azure is actually very complicated. It's a platform with a lot of services. Maybe another quick question too is, do you guys feel that you know pretty much the inventory of services that we have on Windows Azure, or is it still worthwhile to kind of walk over this and tell you guys what we have that you could use? Sounds good. So I'll still do that then, and then I'll make sure that we do a little bit more Java too. So the way to look at Windows Azure, right? So Windows Azure is Microsoft's public cloud platform. It runs in Microsoft's own data centers, and increasingly we're starting to establish partnerships with third-party data centers, and they run Windows Azure kind of extensions. So, for example, that's a strategy in China as well, where we weren't allowed to build and maintain and own our own data center there, but we were allowed to work with a third-party who already have presence in business in China to be able to run Windows Azure services there. So that's one of the strategies that we have. And then there's data centers across the world. I forget the last count, but it's more than 10 data centers across the world. I think 4 major data centers in the US, north, south, east, west. And then in Europe, we have at least 2, which each one is multiple football fields, soccer fields, football fields, large. One's in Amsterdam, and one's in Dublin. So there are good locations in Europe, and there's a couple in Asia as well. So there's data centers all across the world. And what Windows Azure gives you is it's kind of as a developer, you could sit behind a browser and deploy assets across these data centers and take control of thousands of servers, which is kind of cool. And they run all kinds of services. So to kind of walk over this, first of all, you can see that at the top, right? Again, we're trying to say that it's not just .NET. It's not just Microsoft Stack. We run Java really well, and also PHP and any other popular technologies that are used for building server-side technology today, applications today. So what was this? Okay, it looks at so we're getting into more details in one of the layers in that diagram. Somebody built these slides with all the fancy animations. So there are 3 ways to get started with Windows Azure. This is usually what the developers, as we are, the web developers, application developer, this is usually where we enter. Is that we look at cloud as a way to run server-side applications. So we could use cloud services, which is what we've announced back in 2008 or so, and then virtual machines, which is kind of new. So for example, when I came to JFall a couple years back, I only talked about cloud services, how Java was able to deploy on cloud services model, which is a little bit different. If you guys saw that the presentation. With virtual machines, it's new. Virtual machines just went full release this past year, I think. So we went with a different model, and then we provided virtual machines for you guys to use. And websites is a little different. Websites is not for Java, but websites are for things that run behind IIS, for example. And we have a really easy way to deploy PHP, Node.js, and I think Python websites just from Visual Studio directly into the cloud, and you'll have a website running. So for today's talk, I'm not going to talk too much about websites. Just going to tell you what it is so you know what it is. But I'm going to focus more on cloud services and virtual machines, because that's where we can do Java in. And so real quick. Yeah, so this is cloud services. This is what we've had since 2008. This is what we call the platform as a service model, meaning that we first designed this and then made this available so developers didn't have to configure servers, for example. You don't have to deal with virtual machines. You don't have to configure firewalls, privileges, rules, install things on the server, and then to launch it and manage it. The intention there was to take your Java application directly from IDE, say deploy, and you will have something running in the cloud. You don't have to deal with anything underneath your code, per se. You could wire it up to a database or something else, or web servers or storage, but you don't have to you don't have to care whether it's a Windows server running the code underneath. So that was the intention for the the cloud services model, so that you don't have to deal with infrastructure. So we called it at the platform as a service level. It's a higher level abstraction, kind of like Amazon Beanstalk, for example. Very similar to that model, where you don't have to deal with servers. But what that meant, if you guys saw this before, was it changed a lot of ways of how we use Java. Right? It doesn't have persistent drives, right? So we cannot do anything that saves things to the file system. We cannot build things that are based on the file system. It was hard to get more advanced solutions deployed, right? So we could run Tomcat or Jetty or Spring Framework easily, but not so much as in terms of WebLogic or JBoss or Glassfish, the more complicated servers. Because the more complicated servers will probably want more things from them. We want JMS, we want GNDI, we want a lot of clustering, we want a lot of things between the instances that we set up. But Tomcat and the other type of applications are a little bit better. So the other thing was, because these are non-persistent roles, right? So what the cloud services model was ideally intended for is for things that are horizontally scalable. So if you want to build a Facebook, sure, we could do that. But what that means is each node can fail. And the failover strategy is very different than creating your own cluster, per se. Right? So that was a very different model for us to program in. And so we came up with virtual machines that's much similar. But we'll show you what both kind of looks like, just to give you a refresher as well. And then just talk about this real quick, Windows Azure virtual machines. So virtual machines we delivered a little bit earlier this year. And as the name suggests, it's virtual machines for you to use. And it's not just Windows Server virtual machines. You could use a bunch of other Linux as well. So that's very different for Microsoft to be able to support and let you use Linux virtual machines directly. And what this gives you is just the server. And once you have created a server, you can log into it and do whatever you want. It has persistent disks, and so you can install software on it. When it gets shut down, your state is persisted. So whatever you put on that disk, it's saved off and then restarted back for you as well. Right? So you could boot VM directly from a new disk too. Right? So it's much more consistent or similar to how we're working with virtual machines today. So let me show you what that looks like. And you would always start in the portal. Right? So this is the Windows Azure portal. As a developer, once you have an account, so by the way, everything from Microsoft always has a free access. Same thing with Windows Azure. You could either sign up for a 90-day trial, or if you have MSDN, MSDN gives you every month, there's an allocation of free services you can use. So you could try this for free. Once you have an account, you'll be able to sign into the portal. And the portal just looks like this. It's a list of different services that you have access to. Sometimes you don't have access to everything, depending on some of these services. Like for example, HD Insight or some of the other things that we'll talk about. But some of these things are in beta today, I think, right? For example, like BizTalk services. This is still in beta, so you have to sign up in order to get that in your view. But basically, that's the list of things you have access to, and there's some small numbers that kind of tells you what you have deployed under those things. So right now I showed cloud services, and these are different cloud services that I have deployed. This one is what I just did last night. It's a cloud service running a Tomcat application server, and it runs in the cloud service model. And I'll show you guys how that's done later. But I'll show you guys virtual machines first. So virtual machines, and here's a list of virtual machines that I have in my view. And so, for example, and these literally are just virtual machines. So, for example, I can go into this one. It's one of the WebLogic admin servers that I established, which has 2 managed nodes. And here's the dashboard. So when you look at that particular machine, there's a dashboard that gives you kind of at a glance the health and sort of what the machine's doing at the time. I restarted last night, so you see a little spike here. And then if you want to access the virtual machine, for example, you can see click. And then you'll be able to, because this is a Windows server, I'll be able to go into the remote desktop directly. If it's a Linux server, you can set up SSH and you can run any kind of remote shell, for example. You could run an X desktop if you want to. So I sign in. So I'm connecting directly to the virtual machine. Now this virtual machine, does it show on the desktop? The portal right here? I remember it shows somewhere. Right, the location right here is West US. That's very small font for you guys, but the location is West US. So it shows you the location of virtual machine. West US is somewhere in California. That's where the data center is. I'll go through the create virtual machine workflow for you guys. It's very easy. Just a few minutes and you have a server running. Certificate, so I just say yes. And it'll try to, while this is loading, so because right now I'm connecting directly to this virtual machine in California for remote desktop connection. So it might take a while to load. Oh, here it comes. Right, so I signed in, and you can see I was running the latest instance of WebLogic server, and I have configured a cluster as well. I have 2 WebLogic managed nodes and the admin server. Right, so it's actually very easy to sign up, and there's a little white paper that walks through this, but it's very easy to do so. I'm not going to walk through that particular process because that's a process you guys know about. But I'll show you guys a couple of things of sort of what you need to do to enable this. So for example, so let me go back to the virtual machines view, and I'll go through and then actually create a new machine. So let's say a new, and that's new store. So compute, right? Under compute we have these services. What I mentioned earlier is we have website, mobile service is something I can talk about later on as well. That's actually interesting for you guys too, but I'll talk about that later. Virtual machines and cloud service. So if we want to do virtual machine, and then let's do from gallery. And so right away you can see that there's a list of images you can choose from, right? So I'll scroll down a little bit. You could do Windows Server or SQL Server, and as you go down, there's also images already with WebLogic already installed, so you don't even have to, it's already on the hard disk essentially, so you just need to create that image and then go and start up the instance, which is what I did. And then I started a 1 admin server, and then I started up 2 managed roles, opened up the firewalls between them, and then they connected and then create the clusters. Very simple. And go down a little bit more. Right? And then there's even an image with Java preloaded, with a JDK. Of course, you could do this yourself. You could easily do, like for example, I did a Minecraft server earlier. I just created a new image and I just pasted the JDK in there, and then pasted the Minecraft jar file in there, and I started on the Minecraft server process. It's very simple too. So these images actually, there's not that much to these images. It's just the files sitting there for you to use. And then there's also the Linux images, right? So there's the Ubuntu servers and SUSE Linux servers. So these are all things that you can choose from, and then a couple others. The Oracle database on Linux, and Oracle WebLogic on Linux versus earlier was these are on Windows. Yeah, so you have your choice. And that I'll create a Windows server real quick. It's easier to show with a remote desktop. And 2012 Essential Experience. I'll just choose this one. And it's kind of a wizard-driven environment. So, and then you just have to choose the name. If you are ever wondering, like I'm doing right now, kind of forget what the things are. Okay, I'll call it DevOps. And then you could choose the number of cores, different sizes, virtual machines. I'll just do small. New user name. Oh, it's just the user that you use to sign into the virtual machine with. So you could do it all right here. You don't have to. I think we actually don't want you to use admin. So you have to choose some name yourself. And then the rest of it, you can create a new cloud service, or you can add it to existing cloud servers. So for example, when I wanted to create more WebLogic nodes, I can add it to my WebLogic service. So the cloud service is a logical grouping of VMs. right? And so I could create a new one now, or I could add it to existing one. I'll just add a new one now. Subscription is kind of the account that you use to incur charges with. If you have MSDN, one of these will be free. And I'll do North Europe right now, or West Europe. North Europe, Amsterdam's closer. Automatically, availability set, that's kind of like fault domains on the Amazon side of things. Right, and then just say, go ahead. And actually I forget what my mind's not working. 25565, I'll do Minecraft. 255. Minecraft. 25565. 25565. So what this means is every single virtual machine, when you first create a virtual machine, everything is locked down, no ports open. Right now, by default, for Windows Server, we open the remote desktop and the PowerShell for remote access into the machine, but you could remove them as well if you want. But I don't want to. I prefer having some access to it. So if you want to run a web app, you would have to put port 80 on this. For Minecraft, right? So the Minecraft port, and then just say yes. And they'll go ahead. So right now, Windows Azure is in the act of creating this virtual machine. It's finding a physical server it's kind of like hotel room now. We're trying to find a hotel room to put this tenant in. And the server is trying to provision it. It's actually starting. It's found the location. It's starting up the virtual machine, and it's trying to start up the image. This whole thing will take about 10 minutes or so. We'll come back to this, and we'll show you the rest of this. But I hope you kind of get the flow in terms of how to get a virtual machine created. The one step after this is the same. Basically, what I showed you earlier is once it's in a running mode, right? Any one of these guys is running. Once it's in a running status, then you can connect to it, and you can log into it to do things you want. And we'll do that once it's up and running. So for example, like the WebLogic thing, you could do whatever you want there. So then that's probably a good point to show you guys the cloud service model, because we'll come back to this later on to show you a little bit more in terms of what I need to do to get Minecraft running. And here's a real simple Java EE project in Eclipse. So the nice thing about the cloud service model is that we have tooling built into Eclipse. You don't even need to use Visual Studio. You don't need to touch Visual Studio at all. If you want to live your life in Eclipse and you want to deploy to Windows Azure, you could just download and it's all part of the Eclipse. So install new software. I remember I added it. You just need to add that URL, and then there's the Windows Azure Toolkit for Java. The URL is a little hard to read, but if you guys want to know, you can search for it. Basically, the Windows Azure Toolkit for Java, and you'll find that URL to add to your Eclipse. Right, so I've done that earlier. Right, so already installed. So I have the tools built into this. So a very simple index.jsp file in a very simple JSP project to generate the WAR file. Now, so let's say I want to deploy this project into the cloud. What do I need to do? And there's a couple of things. So for example, you could, once you've installed the tools, all of the tools are built into Eclipse. So you can say I want a package for Windows Azure. And I did a Hello World Azure earlier, so I just do another one. Maybe called DevOps Azure. And you could choose to use your own JDK, right? Or you could also, right? This is emulator. So I don't know. Can you guys? Okay. So emulator, with the tool comes with an emulator that you could run on your desktop that emulates the cloud environment, right? Because again, the cloud services model is a little bit different. It's almost like it gives you a container to run in. It's not exactly the same server OS level that you get access to C drive and you can do whatever you want. It gives you a little bit of a sandbox to run in. So because of that, we have an emulator to run this, and then to be able to test, to make sure that your app can actually run in Windows Azure in the emulator first, and then deploy to the cloud. So you don't have to deploy to the cloud in order to see if it works or not. You do it all locally on your device. And you could choose to use your own JDK from this location, and then you could choose to deploy your JDK to the cloud along with your app, or you could try I haven't tried this, so might as well try this right now. Because I used to just deploy my own JDK. Or you could choose one of the open JDK versions that we have in the cloud that will basically use that JDK to run your app. And so you don't have to go through the process of uploading your JDK into the cloud along with your app, right? So there's maybe a little bit of a speed advantage there, but not much, actually. So we can try this. And then the rest of it is pretty, oh, how come it didn't let me? Select server type, that's right, I forgot. So JDK, and then I need to go to server. Yes, terms, license agreement. Use server from this file path. Oh, I need to give them a server as well. So let me use my projects, Java. And let's use Tomcat. The Tomcat directory above the bin. That was one lesson learned. And it automatically filled up Apache Tomcat 7, deploy my local server, again, upload to the cloud. And there's different ways to get your app servers to the cloud, right? So you could pre-upload your application server bits to Blob storage, and then to tell the script to load from storage as opposed to every single time upload your application server as well. Right? So you can isolate that for every incremental build, you only upload your WAR file, for example, or just the application itself. You don't have to upload the JDK and the app server and then the WAR file every single time, even for one-line change. And so that's kind of what this is intended for. There's a lot of different options for you to choose from. And for now, just say auto. Just let it do everything, and then this is my hello world.war file. And you could configure session affinity as well. Right? So that's one of the things that we didn't have for a long time, that because when you create when you deploy an application into multiple VMs, you could still specify, so when you do cloud service, you can still specify how many virtual machines you want to run this app with. You can start with 5 or you start with 10. And you could define rules to grow or shrink that deployment. But as you grow and shrink, what happens to the load balancing and then sort of the session in front of that? Because Windows Azure just does a random round-robin load balancing in front of virtual machines, whether you have 10 or 50. We just round-robin in front of them. And for the .NET applications, we have a little bit of an integration point to know where to point the user session to. Now for Java, not really. So we have to enable sticky sessions if you want a stateful direction routing of your user requests to the number of virtual machines that you have. It's easier not to, so I'll just leave everything as default right now and say finish. As you can see, I created this DevOps Azure project right here. And all it is just a bunch of XML files and configuration files, right? So it's not really touching anything in your applications. It's just additional packaging around your app. So then once it goes into the cloud service, Azure knows what to do with your app. And I think I recall we should be able to deploy. So let's say I want to go ahead and publish, right? So again, the tooling is right there. We already added these. So if I click on this guy, it'll run in the Windows Azure emulator. It'll take a few minutes to actually, yeah. Maybe I'll just click on this and see how fast it turns up. My computer is kind of slow today. So preparing to run, it still has to package it. And there's a little bit of creating the package and then bringing up the worker role one, importing components, copying more than 1,000 files of the JDK. Hopefully this runs fast. Let me check in the oven. So the virtual machine is already up and running, so I can log into this one and do things with it already. But hopefully the emulator comes that fast. I don't want to jump back and forth between different contexts too quickly. But wanted to show that the virtual machine is already up and running, that it's ready for us to use. maybe I'll click connect to open the remote desktop. Use another account because I used a different username as your user earlier. Still copying files. Certificate, say yes. Let me smart size this. First time login, it's setting up the user profile for the admin user. And okay, so build is successful here on the emulator side. So now we're bringing up the emulator. And you'll finally see, okay, the storage emulator. So this, yeah, the emulator is not just the compute. It also has a couple other things in the emulator. There's the storage, which mimics the cloud storage. Because the cloud storage is kind of like Amazon S3. It has a different set of APIs. And we have this for you to do development with on your workstation. And then there's also the queue storage emulator part of it as well. So there's compute and then there's storage for you to work with. Storage emulator started. And it's now finally deploying the application. See, Tomcat server came up. So everything is automatic. And this is exactly what happens inside of Azure when it runs in Azure too. Right? I didn't do anything beyond the project itself other than using the tool to create the package. Server startup. Here's the emulator view. There's a UI to the emulator. So you can see there's deployments in there that you could work with. You could stop it. You could restart it. You could do things as you would on the portal as well. It's a little frozen right now. Wow, my machine's frozen. Okay, the desktop's frozen. Okay, not anymore. And if you look at the deployments, it shows you there's a console view of things, right? So again, that's just the local console. It runs your Java code in a container, fully automated. You didn't have to configure the server or anything. And exactly the same thing as you go to the cloud. Let's see if it's working. It should be working. Let's see. Localhost 81. As you can see, I've been testing this. It should be my hello world. It's the first time I look into that application, so there's no hello world. It mapped to port 81 because it's afraid that I might have some other things running on port 80. So by default, the emulator runs on 81. So that's the emulator, and then we can reset it, but we can also just say, let's go ahead and publish this puppy to the cloud. So I'm going to try pushing this to the cloud. Again, it's just using the UI. There's nothing so even on Eclipse side, there's nothing I changed on the Java project itself. This is all outside of your project, right? This is all just Windows Azure SDK and tools putting things around your project. It loaded my information from my own Azure account because I've done this before. And then again, right, similar to what you saw earlier, when I created the virtual machine, I still need to select a subscription, an account essentially, and I use my own dev account. I'll put it under the same Java service that might as well. Target OS. Sure, it doesn't matter at this point. And you could choose staging or production. Overwrite. Remote access, no need to. And I think just publish. And we should see some status down here too. Okay, it shuts down emulator first. This is more interesting, so it's going to take a while because now it's repackaging it again. So it has to package together everything again and then upload everything. So I'll let this one do its work, and I'll try to leave this down here too, so you guys can see it happening. I'll come back to my virtual machine. So this is the one I created earlier. No, I don't want to share the network. This one just one virtual machine. So, but if you, let's say, like the exercise earlier, I showed you guys the WebLogic instances. If I want to create a cluster of WebLogic instances and talking to each other, because by default, everything's locked down. Even if I create virtual machines within the same cloud service grouping, by default, they don't have network access to each other. So if I want, I remember the port numbers for the admin server access, I need to open it up specifically. But I don't have to create them as an endpoint. So there's that endpoint UI earlier that was used for defining public endpoints. That means external access into the UI, into the virtual machine. You have to define that as part of the service. But for internal access, you don't have to. You only need to deal with internal firewall settings. But you don't need to muck with the external endpoint settings. Oh, actually, it's pretty interesting down here. It's already in the cloud, and it's trying to deploy to but it still goes through the same cycle. It still finds a virtual machine, starts at a virtual machine, deploy your. Basically, what I've done is it deploys. What I've chosen is to use the JDK, so it'll place the JDK there, and then it'll deploy my application, extract all of my contents, and then it'll know that to start up my WAR file using Tomcat, using basically everything set up already, the jar files and class paths and everything. So everything automated. You don't need to do anything in terms of the server to have that app up and running. So while that's doing its work, this is kind of like a cooking show now, where put that in the oven, it's behind me, and then we'll do something else in the meantime. So come back to this. I kind of like this view, just to know that the computer is doing something. And in this case, okay, give me. It's a little bit slow. How much can you guys see? Okay, so you can see that the virtual machine started up with a bunch of drives. There's a temporary storage D drive. There's a C drive. You could also, just like Amazon, you could also map additional network drives into the machine to do file shares and everything else. For now, I'll just do C drive, and I'll create a new folder, call it Java. And I want to now I remember I probably have to do a little more work. 120. So let's do Minecraft first. This is faster. I could just do copy and paste, and it'll upload that file up there. Our network connection here is pretty good, so that actually went by pretty fast. So let's try the JDK then, because I started one without the JDK, so now I have to do this. But you kind of get the idea. It's pretty simple. I'll have to let that do the work. And while that's doing, this is still going, deploying to Windows Azure. So I think both of these processes are uploading files at this moment. But I hope you kind of get the idea. Oh, so on this side, then I can start doing a couple of things, even if we don't get to finish this. Actually, we have enough time. But I want to make sure I talk about the rest of the platform too. So the one thing I need to do my intention is to run Minecraft on this virtual machine. By default, everything's locked down. So the first thing, or the only thing I need to do to the server is to configure the firewall. Because I want to allow this process to run on the 255.65 port, I think. Yeah, 255.65 port. So outbound rules, inbound rules. Actually, both probably. I guess a new rule. Sorry, this is probably too small. The other one's still running. That might take a while, so I'll just open this up a little bit more. Say new rule. And again, on Linux, you would do this differently, right? But this is just Windows Server. New port. TCP 25565. Allow connection. Yeah, everything. Minecraft. Finish. And maybe one more outbound rule just to be safe. I forget whether we need it or not, but might as well. Because I have to listen on that port. 25565. Allow the connection. Same thing, everything. Minecraft out. And then now it's part of the rule set, right? Minecraft right there, and Minecraft right there. And from a server config perspective, that's the only thing you really need to do. Okay, Java's there. Oh, but I have to, was that exe? Yeah, that was exe. So I could do install directly on the virtual machine, right? But the rest of it is pretty straightforward. It's just a matter of getting the JDK installed and then opening up command prompt and then just say run. Just start the Java and then the jar file, and then the Minecraft server will be running. And we actually connect to it and play with it if you guys all have the Minecraft client installed. But let's see, this one is still going too slow. But I'll probably move on to other topics before this one finishes. But I'll show you what, if it finishes, it'll look like. It'll be here. It's not here yet. It'll be placed under cloud services. It'll be this one. So for example, this is the exact one that I did earlier. This was the other project. Running. It's deployed. It's actually because I deployed into this same cloud service. So right now this one is being impacted. But if I create a new service, it will be one of these services here, and then the URL here you could access directly. I don't know if can actually access that right now. Yeah. So this is the one that I had running earlier. This is not the one that I'm deploying. But my hello world, right? So same thing. So this exact same one that I did earlier. So it's running in the cloud. Again, if you guys recall, all it is was just a few mouse clicks on Eclipse, nothing else, right? Just using the tools, which are some of the things up here. Once you install that toolkit, that plugin, all of these will appear, and then will be context-based as well, right? So if you do a right mouse button on the project, you'll have a Windows Azure button there too to use. So it's pretty straightforward. So that's cloud service model, right? Again, if you guys recall, to sum up, there's very different trade-offs and differences between those two models, right? Virtual machines is essentially just virtual machines. You use it as a server, almost like a hosting facility. Just do whatever you want with that virtual machine. With the cloud service, it's very easy to use. You don't have to touch a server. You don't have to put your JDK there. You don't have to put anything there or do any kind of configuration. So the cloud service just kind of sets up everything for you and then launches your app. There's a lot of different things we can do with it. And it's not just built into the app itself. So I've done it with Glassfish before. That was my talk in JFall last time. But I wasn't able to get clustering to work in Glassfish, right? So but if I really wanted Glassfish or WebLogic or the new JBoss server Wildfire to do clustering, I would do exactly the same thing as I did with the WebLogic instances using virtual machines. Because with virtual machines, you get much better access to networking to make sure that the required ports for clustering are open. And then if you do any kind of GNDAI, any kind of GMS access, it'll be all there as well. With the cloud service model, I wasn't able to get that to work to that level, right? But if I'm only running a Java application, so let's say if you want to do a Java app as let's say a mobile front end, a mobile service back end to a mobile device, and this backend only needs to access some databases or some storage services in the backend, and it's mostly stateless, just a bunch of REST services, it's actually really good for cloud services. Anything that's stateless that you want to scale from, let's say, 50 virtual machines to 1,000 virtual machines, it's just a mouse click. Actually, I should show you guys that. So, for example, if I want to change any one of these, it's actually running now. Huh. So it's probably finished deploying. Yeah, it's published. So that took 10, 15 minutes or so, but it's published, so it's working now. But it's running behind that same endpoint, so it's the same result, the Hello World page. But it's done. What I wanted to show you guys is, so let's say if my Hello World service is so popular, I need to create more instances to run. It's this particular service, right? So I can look at the dashboard. It's pulling up some. No, there's not much traffic on my service. So you could configure auto scale, right? So that's kind of interesting. You could auto scale is kind of interesting. You could have Azure monitor your virtual machine instances, even though these are cloud services. They're still running in virtual machines. You can specify that for each virtual machine. If CPU usage is above, let's say, 60%, I want Azure U to create 5 more instances. So you could do that directly in the browser. Same thing as, I'll show you guys the UI. So you could schedule, you could do schedule times, different time zones, almost like programming an air conditioning unit. You could program how many instances, set up schedule times, right? Just all from the browser. So yeah, so that's skill. I want to go to configure. So just showing you guys all kinds of part of the UI. So this is the endpoint, right? So if I want to add more public endpoints, this is where I would add them. Let's preview. No, that's the other endpoint. That's another endpoint. Sorry, this is completely brand new. Here's instances, and worker roles running. Actually, where's my? Here's monitor. One core, 8 of 2 cores. Configure web boundary. You could do it from the. I remember. So this changed a little bit, so I forget where we changed it, but. You could change it on the portal to say from 5 to 10, for example. You could just change it right there. I forget exactly where we change it now. I actually haven't touched my web cloud services for a while, but just trust me that it's on the portal somewhere. So again, so just remember that these things are very different. They both have some benefits to them, but if you could choose either one. Either one works. So go back to the presentation. Any questions around this? So going back to the presentation here. Right, so virtual machines is where we left off. Key scenarios. Also, this is actually kind of nice to talk about because this one kind of helps you decide between cloud services and virtual machines. Yeah, migrating existing applications, right? So anything that works at the OS level, you could always put it there. Whereas if you're writing new apps, like I did, let's just basically Hello World app, it doesn't have any dependencies to anything else, to the file system, to other software components that you install on the file system, or to a application server that has specific services that you need to use. If you don't have these dependencies, it's really good to use the cloud services model. Let's say if you have a database backend, because you could put the data into a database, and then all you need to do is just change the connection string, and these different instances can access that database as a backend as well. You don't have to install your own database too. We'll get to that because it's part of the server, platform stack as well. Hybrid and cloud bursting, I don't know about that, but so different scenarios that you can use. Virtual machines obviously is just very similar to traditional hosting scenarios. Windows Azure websites, I didn't get into this too much, but this is another really easy thing to do for building websites. There's a lot of, Microsoft putting a lot of attention to this, but it's not so much for Java because we didn't put in a Java runtime behind the web server for you to automatically deploy into. Right now, this is much more of Windows Server environment, and we enable Node.js, PHP, Python, and .NET runtimes. So you could just take your code and then say, very similar to what you saw on the Eclipse side of things. You just code your application within Visual Studio in a website project, whether it's ASP.NET or PHP or Python and Node.js. You could just say, from Visual Studio, go deploy, and then you will have a website running in a couple of minutes. And then there's other deployment methods, like continuous testing methods, continuous integration methods, through JIT and FTP, and a lot of things that's automatically integrated in there. So it's a very nice set of tools, but it's not exactly Java right now, so I'm not going to get into too much of it. But just to keep in mind, that's another option as well, if you want to use any other languages. And this will be done in Visual Studio, of course. This will not be done in Eclipse. And so, sorry, so I think, so we're jumping from compute. If you look at the top, we're jumping from compute to data management. Compute is where we place our application code most of the time, right? So in compute, we talked about cloud services, we talked about virtual machines, and then the websites, that's where the application code goes in. Data management is where data goes, right? So if you want a database, you don't have to get a virtual machine and install your own database, but you could. In terms of the virtual machine images you saw earlier, you could start up an Oracle database on a virtual machine. And you could also start up a SQL server on a virtual machine, but we have a lot of other options too. As you see, there's the SQL database, and then there's also a NoSQL database, and there's a Blob storage. So again, if you looked at Amazon or if you looked at Windows Azure before, this should not be new to you. But just understand that there's a lot of different options to use in that area. And this one goes into some of these, actually it goes into these different options. SQL database is very interesting. So it's a database as a service. Ultimately, it's still virtual machines running SQL Server databases, but you don't have to configure or install SQL Server at all. It's a few mouse clicks on the browser. Let me show you that too. This is kind of interesting to show, and you will get a database right away. So SQL databases. So let's say create a new database. Just a quick create. I just want something really quick. DevOps test. Again, my own subscription. Give it a new SQL Server, login name as your user, my password, and say create database. And you'll see that it's going through creating the database. It's still allocating a new server because it still has to place that database on a server on the virtual machine, but it found the server. Right? Now the name just appeared, and the database is online. You have a database to use now. Right, so that's pretty nice. It's a SQL Server database. It's a full SQL Server database. Now, what's different? I went through quick create, so I didn't go through some of the options. But the options are like different editions and different sizing. So you could choose different sizes. We support different sizes. Now, what makes this different? As you can see, because it's a database as a service. But what makes this different? Is actually what's good to talk about on this slide right here, is that it works in a multi-tenant model, right? It's not just your own dedicated virtual machine running a particular SQL server. We have that option too, but which is the virtual machines method, where one of the virtual machine images is a Windows server running SQL server. You could have that. That's dedicated virtual machines. In this case, it's a multi-tenant model where there's thousands and tens of thousands of SQL Server instances running in a part of actually distributed throughout the Windows Azure data center. What we've done is we picked 3 different nodes across different fault domains to place your database logically in that physical server, in that logical SQL server. And the failover or the reliability model is very different than traditional database clustering. It's not exactly clustered. It's what we call not three-phase commit, but every single logical database has 3 physical replicas in our data center across different fault domains on different servers. So what I just did just now, when you saw that I worked through the browser, well, I tried to create a DevOps test database. I only specify 1. But what happened underneath the covers, we actually created physically 3 different databases. And then what happens is if I create an application to work with that database, there's a load balancer up front that actually goes to, so for the 3 replicas, back up real quick, there's always one that's a master, and then 2 hot replicas. And there's different things we do underneath the covers. Sometimes we would distribute or load balance the read requests across the 3, but most of the time write's always going to 1. And let's say commit then. Commit is a core and commit model where we always commit to 1 and then asynchronously say commit to one of the other 2 replicas. We have to have at least 2 commit OKs coming back to that sort of the fabric layer for the database to return to your application to say that commit is okay. And then the third one will catch up to eventually, right? But we have to have at least 2 to say okay. So that's kind of the core and commit model. What that gives us is at any point in time, 2 replicas should be up to date with whatever commits that you're doing. And if the primary goes down, we can just use the second one to service and then try to bring up another one in the cloud and then let this one to catch up. So it's a very different reliability model than having your own large servers running large clusters, right? But what the benefit is the real quick to create and real flexibility in terms of getting something running really quickly, right? If you want a SQL Server database for dev and test, that's really easy to do. You saw it was pretty much under a minute that you got a database working inside of our data centers. The only thing is that there are size restrictions to this, so they're not exactly. I forget exact sizes, but let's see. So you go to Azure.com. If you look at pricing, I remember the best things to look at is calculator. Because of that core and multi-tenant model, we don't give you 1 terabyte or 1 petabyte databases like that. Data management, storage. Where's my SQL? So here's my SQL database, right? So web and business. So if I say, you could see the gigabytes go up. I think we go up to, right now we go up to 150, but I think we announced 200 and it's coming very soon. So right now the max is 150. It's because of that setup model that we cannot just give you a really large database. And the price goes up, right? So, but if you use a 1 gigabyte database, which is what I just did, and if it's only $10 USD a month, which is pretty nice. Right? So for dev and test, it's actually really perfect. And sort of we designed this again for really horizontal scaling scenarios. So let's say if you could deal with partitioning your database into hundreds or tens of hundreds of single databases, and you could deal with that partition, and you could have your application work that way, maybe like a REST-based service stateless kind of application, you could do this really easily. You could have hundreds of these as opposed to 1 large database. The SQL Database Premium, okay, I remember that. This is the one that goes up a higher size, I think. Yeah, this one, and the higher size SQL is, say, this is 1, and then we go up to, oh, still 150. I forget what's the difference here. Yeah, I forget what's the difference here. SQL, oh, okay. They've been changing the name. So I think this is the one, premium, premium kernel preview, okay. So this is not it. Because, let me go back to just show you the full view, because I think the other one that I talked about is under virtual machines. So Windows virtual machine, Linux virtual machines, here's SQL Server, right? So this is your data, your dedicated SQL Server on your own virtual machine. And 1 small, and then I think just 1, right? So the price is very different now. It's $100 a month. Yeah, $100 a month, as opposed to $10 a month on the other option. Again, these are retail pricing. If you have, if you run up the bill, there's ways to get discounts. But this is kind of like buying Office from your convenience store. It's the retail pricing. So that's SQL database, right? Which is really interesting because it gives developers something really easy to use and that you spin up really fast, and it's really good for different kind of applications. Not for traditional vertical scaling applications, really good for horizontally scaling applications. And then the next one is a SQL Data Sync. SQL Data Sync is a tool that we can use to synchronize databases across different environments or different data centers. So if you have a SQL Server here, and then you have a SQL Server in, let's say in SQL Azure, SQL Database in Azure, and the SQL Azure, a SQL Server database in your own data center, you could use this tool to bidirectionally sync changes into the databases. It automatically does that. So that's a tool, just know that it's there. Some people use this as a good strategy to maybe, let's say, use a master database in your own data center as a publication catalog. And then you have a lot of read replicas in the cloud. Use this to publish your changes out there, right? So that's very, very simple. You don't have to set up anything, just say the tools to connect. Here's table storage. Table storage is kind of the NoSQL storage under our storage services options. It works just like Cassandra in terms of the programming model, right? You just use the hierarchical account table entity, table bag entity kind of programming model. So we have this service running, and the interesting thing again is this runs in a multi-tenant mode. It's not just a piece of software that runs on virtual machine. In fact, when you deal with this particular service, it's just like working with S3, Amazon S3 and Amazon SimpleDB kind of environment where you don't have to deal with virtual machines at all. You just say, I want to store 2 terabytes of horizontally scaled NoSQL data, and they're name value paired, for example, a lot of stuff that I just throw into these bags. And what we do underneath the covers, we actually you could define a partition key, but even if you don't, we try to spread these throughout hundreds of thousands of servers, depending on how much data you have. So we can use hundreds of servers to service your requests across the data set, almost kind of like how Bigtable from Google works as well. So we take a lot of the best practices from distributed storage and NoSQL storage from the other implementations and put it here as well. So again, that's something in Azure that you can use directly. You don't have to spin up your own Cassandra. You don't have to spin up your own implementation of a NoSQL table storage. You could just use this. Same thing as blob storage. Consider this to be just large file storage. We support up to 2 petabytes of files. I recall, maybe bigger by now, and you can manage large files by blocks. So you could for like a 2 petabyte file, if you make a change, you don't have to always upload the entire 2 petabytes of that file. You can upload a few blocks that changed, and we'll be able to update those blocks as well. Things like that. And it still follows the same NoSQL storage was kind of the grouping, the account, the container, which is kind of folders, kind of like that. And then the blobs are placed under. And you could put anything in blobs. You could put any kind of file, binary files into the blob storage. So like a lot of times what I did before with Java projects was I put my JDK in the blob. I put my Glassfish or my WebLogic binaries in the blob. And then what I do is in my worker role, the cloud service project before, I have a little script that says, when I start up, pull my JDK from my blob, which is a zip file, and then unzip it to this directory location. Take my WebLogic file, unzip it, unjar it into this location, and then put my application jar file, Word file, whatever, in this particular direction, and then I have this little line that starts up, basically a class path and everything all configured. So the benefit is for my cloud service, then I only have to move up, upload my own application. I don't need to always upload my JDK and the application server. So you could use the blob storage that way as well. And of course, as you build the application, you could use this blob storage to store anything in terms of static content, images, even HTML files or JavaScript files. You could all place in there as well. And there's networking. So the networking services in the cloud. And they can be used to extend your network into the cloud. Again, so they're kind of like VPN solutions, where you could have your machines in your own data center, your servers to connect to virtual machines in the cloud directly, and establish a secure tunnel. And then so Windows adds another layer where you could have the virtual machines, let's say Windows Server virtual machines in Windows Azure, to be part of your own Active Directory group in your own domain on premises, because of this whole virtual machine, right? So you can manage them in that way, and they could take advantage of the identity and memberships that you have in your own Active Directory too. So that's a lot of the ways where that virtual networking is used today. So this is the Windows Azure networking that I just talked about. It could be used to use cloud-to-cloud connections or cloud to on-premises. That's usually what it's used for. Traffic manager. This is a little bit. So this is something that's different from Amazon. We have this traffic manager to help direct traffic to the right data center in a way. Right? So because sometimes you might have an application that's deployed in Europe, in Asia, and in the US, and you want to be able to direct customers in Europe to only hit your services in Europe, as opposed to routing them all over the place if we just do a random round robin on that public endpoint, right? So the traffic manager kind of helps with that. It makes sure that it's load balancing correctly, and then makes sure that the right users are routed correctly. And again, the overall view again. CDN is one thing that you can take advantage as well. So we have a CDN and a network of CDN servers across the world. A lot more than the compute data centers that we have. I think we have over 100 different nodes. Still not as big as Akamai. We're not trying to be Akamai or something like that, but at least we want to fill in between some gaps between the application servers themselves and the endpoint. But these can serve as endpoints too. There's an in-memory caching service. So just like Memcache, there's an in-memory cache, distributed cache service that you could use. So instead of installing, configuring your own Memcache, right? So like I mentioned earlier, instead of installing, configuring your own Cassandra, your own things, there's things that you can use in Windows Azure directly as a service. You just fire up the API, call it, and it'll interact with that service directly. Of course, you get charged for how much you use, but that's a trade-off. In-memory caching, so it could serve as a lot of different caching for many different tiers of application architecture, depending on what you want to build. That's really small fun. Yeah, it just talks about local caching for increased performance on the front end, in the front end web tier architecture, or you could use share session state across web instances. Right, or sharing data across sort of that data cache tier in front of the databases. So, so this service can be used in all these different tiers. Integration. So there's a service bus solution that we have for conducting messaging. It's not exactly an enterprise service bus, but think of it as Skype. Sorry, my brain fails me. Think of it as Skype for applications. Because sometimes you might have applications that run behind, so for a lot of peer-to-peer connection scenarios. If you run it behind network as translated environments where in residential zones or behind corporate firewalls, but you still want to enable peer-to-peer connections, this rendezvous service in the cloud allows application clients and servers to connect to and then sort of redirect connections and messages between. Right? Because if you connect outward from a protected zone from inside of firewalls, you don't have to open the firewall hole in order to listen in, right? Because you're not listening on the hole. You're actually putting your endpoint there, a socket connection to the cloud service, and you're listening there. And we're just rerouting connections down here, the messages that way. Right? So it's an interesting concept for connecting applications that in some networking environments that cannot be connected. And then, of course, we have, on top of that connectivity option, there's the typical queuing APIs as well for get and push and the commit and the typical, almost like GMS-like kind of scenarios. SQL reporting. So this is also, we have business and analytics. So there's a SQL reporting service, just a reporting service that runs on top of SQL Server that you can use directly. You just point it to a database and it'll run SQL reporting. And then there's Hadoop services as well. I think the next slide probably talks about that. So more details here. SQL reporting, not that much, nothing too complicated here. So the Microsoft Big Data solution is that we have Hadoop running as a service in the cloud as well. And you can use this as a service directly. Again, so you don't have to build your own Hadoop cluster. You could use our Hadoop service to pull in data sources into the Hadoop cluster and then do things on top of that. And then there's a lot of front-end tools that we have built in to use that service. And then there's things that you can do to program things that you want to do with Hadoop as well via JavaScript. And I think some other programming models. I'm not too familiar with the programming model on this, but just kind of know that Hadoop service is there for you to use. And then identity security, of course, that's a major layer on the Windows Azure platform. We have Active Directory running in the cloud, so you could use the Active Directory in Windows Azure to act as your identity store, for example. If you want an identity store, you can have it in Windows Azure, as opposed to always coming back to your on-premises identity store. You could use the identity store in Windows Azure to do federated identity. You could do identity replication. You could do federated identity. You could also integrate with other online identity ecosystems like Live ID, Google account, Facebook account, Twitter ID. All these different accounts can go through that, and then you could use one single programming model to use that for authentication, authorization purposes. You could also define, right? So Active Directory is kind of that centralization point from all the online ID repositories that you might want to use. And then the other side is the APIs that provide for your applications to use, and then kind of the roles and privileges in the middle that you can define against the methods that you want to use and against the rules that you define, roles and privileges. So that's, again, you could easily integrate Live ID, Facebook, Yahoo, Google, and Active Directory application for application single sign-on. Right? So applications, you can have multiple applications that work with that Active Directory and enable single sign-on across them using the same APIs. And here's just a diagram for what I just talked about. That's the interesting point here on the diagram is that it's also for enterprises, for companies that use Office 365 or Microsoft Dynamics, and when they want to use a seamless way to sign in or use existing identity to sign in, this is also Windows Azure Active Directory that kind of helps manage the identities for access control into those applications as well. And another service is called Media Services, Windows Azure Media Services. This I think is something that Amazon doesn't have yet, but it's a little bit of a different scenario, where you think of it as an end-to-end media service where you could upload videos and we could encode, we can encrypt, protect, basically media encryption, right? Content protection, and then to be able to distribute throughout the, basically deliver and distribute the content to endpoints, essentially. So kind of an end-to-end workflow to allow content providers to be able to get protected content into users' hands. There's actually a lot of things to this, especially when you deal with the content protection in the middle. So for example, when we talk about encoding, we can encode into different formats. It's either live or on demand. Live is even more complicated. Format conversion, and then we can add in content protection for on-demand streaming and live streaming, and then there's analytics built in. So the media service encompasses all these different capabilities. Whereas before, right now, if you're a media company and you want to do this, it's actually quite a lot of undertaking to piece together your own implementation to make that happen. So we made this to make it easier for those companies. And then there's the HPC. Okay, so real quick, HPC and Commerce. There's not that much to talk about. HPC is high parallel compute clusters. That's another part of the technology that we have. In Commerce is we have a store that you can publish your solutions into as part of the Windows Azure ecosystem as well. So very simple things, straightforward. And coming back to the large picture again. Oh, actually, that's it. So any questions? Any questions in terms of Windows Azure, or any specific thing that you guys want to dig more into? Because we have a little bit of time left, so I want to make sure. Is there anything deeper that you want to get into? If not, then okay, question.
Yeah, I'm just wondering, you're using Eclipse. That means it's used for a lot of web applications. Is there any development on creating a plugin for Windows Azure for NetBeans?
Oh, for NetBeans, I haven't heard of it yet. Unfortunately, so the question is, you guys saw Eclipse, and there's a lot of focus from Microsoft on making sure our tools work on Eclipse. And the question is about whether those tools will make their ways into NetBeans. I don't know. I have not heard of that yet. So, sorry. Eclipse is a step forward. I think one question.
I have a question about the Windows Phone development. The emulator that we saw, is it any good? Is it fast or is it like standard or Android? Yeah. If you want to experiment with it, should you buy a Windows Phone or are you okay with the emulator?
Great question. So the question is about Windows Phone emulator. Whether it's fast, is it good? So the couple of things I want to talk about that, and I forgot to mention that earlier, is definitely all of the tools are free, and let me get into that. Let me get into that real quick. Even Visual Studio, to use to build production apps, can be free. So Visual Studio has a lot of different SKUs, different editions. Remember, if you guys search for them, search for Visual Studio Express. They're a little bit hidden. They're not directly on the Visual Studio website. So actually, I search for Express a lot, so you can tell. There's the Express edition. Yeah, freeware. See, there's even download from some other websites. Probably this link. So make sure you search for Visual Studio Express. So that's the free edition, and that comes. So let's say, for your question for Windows Phone. Let me just try to find that on this. It should be on this page. Now, for Express, we made it into different editions again, but it's all Express. It's just for, you'll see as I scroll down. We made it Express for web, for building web applications, Express for Windows, for building Windows applications, desktop, and Team Foundation, and then I think finally phone. Right, so for you, this is the one to download. It has the emulator, right here. With emulator built in. The only thing for Windows Phone development is you guys have to keep in mind is that, can you guys see that now? Let me make the page bigger. Because that's an important point. Not all machines support Windows Phone development right now. The Windows Phone emulator requires virtualization access, so it requires this second level address translation. The newer machines have this. The older machines don't. So that's a requirement on the hardware for Windows Phone development. But other than that, you can download this. It's for free, and you could use this to develop and publish fully functional applications. Of course, what I use is Ultimate, and Ultimate has a lot of other tools, but this is fully sufficient for building an application. And the emulator is pretty good. I can try to start that up again. Actually, okay, so this one's still here. So I shut down the emulator earlier, and I could start it up again, and you can kind of see. My machine is still a little bit slow today, but let's see. Okay, emulator came up. So this should be that Contoso app again. So I'll show you guys this on the site too. I have a lot of stuff loaded on my machine. Usually it comes up pretty fast. And you could keep it in memory too. So what I did earlier is I actually kept it in memory, but I shut it down before I went into the Azure talk. So now it has to start up the OS and start up that emulator again. And once the emulator comes up, you can play with it. It's a little bit slow right now. Right? But you can kind of get that Windows Phone feel. And where's my app? Oh, it still hasn't deployed my app. Oh, right here, Contoso Workbook. And debugging is a little bit slower too, because Visual Studio has its hooks into the emulator right now. Yeah, but the emulator actually gives a pretty good representation. What you see on the emulators is exactly what you'll see on the device. But I do recommend getting a device, especially getting what we call the lower memory devices, because Windows Phone comes out in different versions as well. They're in different hardware formats. The Nokia phones are the high-end ones are higher memory. The lower-end ones, like the 520, 521, 520 and 521 are probably the best-selling ones right now. They're the lower memory ones, so basically 512 megabytes of memory. So usually we recommend, like for example, even when I ran the emulator, I ran the, oh, I don't see it right now, I'll just stop it. But the app is still running there. Right, so I tried the, you can see. So I did the lower memory emulator too, but you could choose to run different kinds of emulator as well. Because on the PC, you could do anything. But on the device, we still recommend you get a device. We do, and get a lower memory device. And I'll say that you try to find one of us, or Microsoft has a lot of evangelists or even programs running around. There's ways to get your device to work with. Just make sure you contact Microsoft people, and then we'll figure out a way to get your device most of the time. Now we have. It's not like we have unlimited supplies, but it's a program we have to go through. We have to justify saying, hey, you are building something interesting, and let's get you a phone kind of thing. It's not like we have a lot of stuff in our back pockets. Here's a phone, but it's a process that's available that we can work with you. We will love to work with you to try to get you a device to work with. So just make sure tools and everything are free, but also reach out to us if you're interested to build something. We can figure out if we can get a device for you. Thank you. Any other questions? If not, then thank you so much for your time. Thank you so much for sticking around. And let me know if you got my email address is david.chou, Chou, david.chou@microsoft.com. If you have any questions, let me know. I'm a little bit more on the Azure side of things than Windows Phone, as you can tell. So apologize if the Windows Phone part was really boring for you guys. But if you guys have more in-depth questions, feel free to let me know. I also do Windows development too. So like, for example, when you want to move, for a lot of you that have built Windows Phone apps, you want to move your Windows Phone app to Windows Store, it's actually a really good time to do that as well. Windows Phone, the growth is a little bit picking up right now. Windows itself is kind of behind, right? But it's going to get to that point very quickly. So our push has been to get people who have built Windows Phone apps to try to hop on the bandwagon for Windows as well, because very quickly it's going to be like that. And especially this holiday season, you will see the entire PC ecosystem come out with all kinds of tablets that should be much better. The Nokia tablets are pretty cool, actually. They're running the Snapdragon 8. I think the CPUs are really fast. The graphics really awesome. So hopefully after this holiday season, you will see the entire PC ecosystem work a lot differently than before. It's not just clamshell laptops like this before. You'll get a lot more tablets, and you get a lot more different form factors. You get small screen tablets as well as large screen tablets, or even the large screen monitors that you can touch as well. So all kinds of things you can do. And Windows Store apps target those environments. Windows Phone is really Windows Phone. But we would love to take your Windows Phone app to Windows Store as well. So please feel free to let us know if you have any questions. We have a lot of evangelists running around in Belgium and in Europe as well. We would love to connect you guys to them as well. Thank you so much for your time and attention. And again, just thank you.